This video is aimed at people like mathematicians, familiar with LaTeX, but who maybe live in the 21st century where an online presence is important either for themselves or maybe for a group or an event that they're running. For many cases, less manual options might make more sense, such as no-code solutions like Google Sites, Squarespace or Wix, and in some other cases static site generators like Jekyll and Hugo are also great options. Despite learning raw HTML not being a required skill set to create websites, there's a good chance that some knowledge on the topic will end up being useful no matter what option you end up using. And it also gives you an option to go full manual if ever that's necessary. Now, the good news is, if you are familiar with LaTeX, in many ways HTML as a language is much simpler, or at least much more uniform. In this video, we'll take a tour concentrating on comparisons with what you may be familiar with in LaTeX already. Creating a PDF document with LaTeX first involves writing a LaTeX script. This is a text file that you can open in any text editor, whether that's a dedicated LaTeX editor or just Microsoft Notepad. Here's a short example starting with a preamble with details about the document as opposed to content directly appearing in the document itself, followed by the document environment containing content and commands populating the actual document. Commands like section here. However, this file is not the PDF itself. To create the PDF, we run a LaTeX compiler directly or indirectly, and finally we get the PDF that we wanted. Now, for an HTML document, we create a text file in a similar way. In this case, we might give it a .html or .htm extension. In this example, we have a section somewhat similar to the preamble, containing stuff that doesn't directly refer to content appearing on the page. And then we have a body element reminiscent of the document environment in LaTeX. However, instead of converting it to a document before sharing, I can just double click on the file to open it in the browser, which is most likely the default program for that file on your computer too. The browser itself understands the HTML and renders the page appropriately. If you were to make further comparisons with the LaTeX flow, the browser would correspond to both the LaTeX compiler and the PDF viewer. In LaTeX, some structure in the language is dictated by these / commands, like here with section, and then we have arguments immediately following in curly brackets. Here we have a section heading with the argument in curly brackets saying literally heading, but at the same time these / commands can sometimes also have optional arguments in square brackets. And also there's this other form of structure here with the tick CD environment, where the tick's commutative diagram isn't given in curly braces to a / command, but is instead placed between the begin and end commands. But that's not all. We also have special characters with special meanings in certain environments, such as the ampersand, double / and dollar symbols. Now, on the HTML side, there's less ways to denote structure in the content. The document is formed of nodes, which start with an opening tag, and at the end, a closing tag, like this body node here. Then inside these nodes, you will either have plain text or further child nodes, and that's how the hierarchical content is represented. In the browser, you can also view this hierarchical content by right-clicking and choosing Inspect Element. You can hover over nodes. The relevant parts of the text will get highlighted, as well as the relevant part of the page. The one extra form of information that can be encoded are node attributes, which are added inside the opening tag, like so. In this case, giving extra information about the styling for this heading via some inline CSS. In LaTeX, we have the following / commands: section, subsection, and subsection to create headings of varying strength. If you wanted to go any lower, so to say, you could potentially write something like this to add something in bold with no numbering. In HTML, you can use the H1 to H6 tags to create headings, H1 being more important, bigger heading, and H6 being the smallest, least important. In LaTeX, just writing text will create a paragraph, and adding 2 new lines will trigger a new paragraph. On the other hand, in HTML, paragraphs need to be explicitly denoted as nodes. Notice that adding new lines will also have no effect. In fact, any sequence of new lines and space characters will only ever be interpreted as a single space on the page. And as you see in the browser, we have 2 paragraphs, with the second one not broken where we added the big gap. Also note that in LaTeX, the first line of each paragraph apart from the first will be indented, something that doesn't happen by default in HTML. Next, it's worth pointing out some behavior with special characters in each language. In LaTeX, the ampersand is a special character, so you would need a / in front of it to use as a normal ampersand. But also, some special characters like this mu here will cause trouble with PDF LaTeX. However, if you were to use a more modern engine like Lua LaTeX instead, you would be able to get a bit further without manually telling PDF LaTeX how to deal with the special characters. One caveat here is that the font may not even have the character that you want to use, as is the case here. And as we can see, we don't get to see the Mu character in the main document. However, in HTML, there's less of a concern here. In this example, all these characters show up absolutely fine, but for some characters and browsers, you may need to use what's called HTML character codes, which you can look up for any given character. Here, I've used the character code for ampersand. Historically, you would have needed to use character codes for a lot of these characters. If you ever remember seeing strange characters instead of the pound currency symbol in past websites, that was probably the reason. But in my testing, it seems that most browsers are fine with raw characters nowadays. In LaTeX, we have two environments to create lists: enumerate and itemize, the first for numbered lists and the second for just bullet points. Within these, each item is marked with a \item command. In HTML, the corresponding tags to enumerate and itemize would be OL and UL, which are short for ordered list and unordered list, with the list items contained within subnodes with the LI tag, instead of just having markers at the start of each one. Now, for tables in LaTeX, we have various environments available, such as tabular here. New rows are marked with double backslashes, and the next cell in a row is marked with an ampersand. On the HTML side, there's a similar theme going on as before. There are no markers for divisions. We have an opening tag and a closing tag around each subdivision. Here, the tag names used are table for table, tbody for the body of a table, tr for table row, th for table heading, and td for table data, i.e. a cell in the table. I included a few borders in the LaTeX table here as an example, but by default in HTML there won't be any borders. There are a couple of methods to add borders in HTML. A good way is to add what's called CSS to the page. This would involve adding a style tag within the head node and specify some stylings a little like this. Now, there are many combinations of things that you could do here. I recommend doing your own research elsewhere for more detail. If you want to include some mathematical formulas in your webpage, the easiest drop-in solution is MathJax. This website gives you a line of HTML code that you can drop into your webpage, and that will allow you to write snippets of LaTeX in amongst your HTML, which will automatically get rendered. Alternatively, you could also look into KTeX to achieve a similar result. A completely different alternative to MathJax is called MathML, which is a form of XML, looks similar to HTML, but is used for denoting mathematical content. In recent years, this has received major support from browsers and is a feasible alternative to use. The most convenient way to generate MathML from LaTeX snippets right now is using the teml.org website, where you can paste your LaTeX into a text box and it will give you the corresponding MathML code along with a preview. This MathML code can actually be copied verbatim into your HTML code without any extra scripts, and it should work out of the box. You can see here that I can actually select the content as the browser renders the MathML itself, as opposed to some external JavaScript library. This ties into one of the big ideological reasons for MathML, which is that it improves accessibility of mathematical content of a web page. In particular, it is much easier to digest with screen readers, helping the visually impaired.